Welcome back, students who are taking Math for Business and Finance and Math Applications, and we're working on the theory videos for Chapter 22, Business Statistics. And if you've been following along by now, you know we're working with standard deviations. And in the last video, I had given a simplistic example of standard deviation with me just thinking about it through my, from my head. There's a 6-step process, and if you follow the process, and you do what you follow the steps, you shouldn't have too much of a problem. Probably the hardest part is getting the square root, which is step number 6. But basically, that's just taking your 3. If you have a very simplistic calculator, you punch the 3 into your calculator and then you hit the square root key and it gives it to you. Okay. But you saw me working through the simplistic example, but now let me go over what is actually in the textbook as illustrations. And like I said, I don't memorize those steps because if when it comes to standard deviation, when I need a calculator, I'll actually look at the steps in the book. But honestly, I don't read the steps. What I actually will do is I will look at these illustrations right here. They tell me how to use it because I've done it enough times so that I understand the concept and I know what's happening from step to step to step without having memorized it. I'm just using these illustrations just to be able to follow along with the steps. Now, this textbook does not present you the formula, okay? Again, it's a shortened version of what you're going to learn in actual, business statistics. There is a formula for standard deviation, and you can memorize that formula when you get to there. But I kind of never really used a formula, okay? It's one of these things where I don't like memorization and I do like understanding a concept. So even though I don't know and I haven't memorized the standard deviation formula, I can actually look at the information that you see on the video here and know how to calculate the standard deviation without going through the formula, because these illustrations are based upon that formula. So let's back up a little bit. And if this is going to get, a lot, it's going to start to become complicated. So pause the video, rewind it, watch it a few times. If you watch the previous video, you should have some inkling as to what's going on in this video. But at the end of this video, if you're still lost and confused, go back, watch the previous video, number 5, along with this. And if you're still not getting it, I mean, obviously read the textbook, okay? But if you're still not getting it, telephone and speak with an instructor, and we'll try to work with it and work with you so that you do understand it. Okay, so standard deviation, okay. What they're showing here is, it says the mean is the same, but the data is dispersed differently and the frequency is different. Okay, so we have 2 sets of data here. Okay. And in data set A here, as you can see, they have from 0 to 13. All right, those were the possibilities, and you can see that the 1 was used, in frequency, the 2 was used, the 5 was used, the 10 was used, and the 12 is used. Okay, so in other words, let's say they had 0 through 13, on a piece of paper in a hat, and they pulled out a 1, they pulled out a 2, they pulled out a 5, they pulled out a 10, and they pulled out a 12. Okay, you can see the frequencies of this particular data set, because you can see that 1 was pulled out once, 2 was pulled out once, 5 was pulled out once, 10 was pulled out once, and 12 was pulled out once. But when they did it a second time, you can see that the only numbers that were pulled out were a 4, a 5, an 8, and a 9. Okay, and in this case here, for data set B, the 4 was pulled out twice, the 5 was pulled out once, the 8 was pulled out once, and the 9 was pulled out once. Those are the frequencies. For data set A, the frequencies were 1 was once, 2 was once, 5 was once, 10 was once, and 12 was once. When they did it a second time, they ended up with 4 had a frequency of 2, 5 had a frequency of 1, 8 had a frequency of 1, and 9 had a frequency of 1. Okay, so that's what it means. You know, if we look at the mean, okay, and we're looking at the mean here, and we can see, well, what's the mean? Okay, so the mean is an average. So we had, you know, a 1, a 2, a 5, a 10, and a 12. When we add them all up, all right, and then we divide by, you know, there was 5 there's 5 frequencies here. So we add them all up and we divide it by 5, we ended up with a mean of 6. And the same thing over here. You know, we see the 4 was pulled, the 4 was pulled, a 5, 8, and 9. Okay. The numbers were pulled on both sets. They were pulled 5 times. Okay. But the mean and the mean actually ended up being the same. Okay. So the average for data set A and the average for data set B both ended up being 6. However, the frequency was different. Okay. You could see the frequency being, you know, the 1, the 2, the 5, the 10, and the 12. That's different from the 4, the 5, 8, and 9. Okay, so even though we have the same mean, we have a different frequency. Also, the data is dispersed differently. Okay, well, over here for data set B, the data is dispersed between 4 and 9, meaning that's its range. The range being the high value of 9, right? And the low value of 4. Okay. Well, over here, the range for data set A is the high value was 12 and the low value was 1. Okay. So the dispersion is different. Okay. They can, even though the mean is the same and we pulled them 5 times each, the dispersion can be different. So, you know, with a data set, your dispersion can be different and your frequency can be different. But I want you to notice that, you know, so far we haven't even talked about standard deviation, but I've used the concept of the mean, I've used the concept of dispersion, I've used the concept of frequency, and I've used the concept of range. Okay, so that's why I had said in the previous videos, okay, that you have to understand the underlying concepts, because they're always, you know, every concept that you're presented, one builds upon the other. It's a cumulative effect. And you have to be able to use that information in order to be able to understand the higher levels of knowledge here, the higher levels of thinking. And we haven't even started talking about standard deviation yet. We're talking about the same data, but we haven't even, you know, gotten to the standard deviation. All right. So with that said, I'm going to pause this video here because I only have one more slide. Okay, one more PowerPoint slide to cover standard deviation. But you want to grasp all of this before we get into the nitty-gritty in this next slide here, okay, on calculating the standard deviation. Okay, this illustration here is the exact same thing as this, and it's a copy. Okay, so, you know, when I come back in the next video, you have to understand what's on this illustration, all right, in order to be able to calculate the standard deviation, you know, for data set A and for data set B. Right? So with that said, I'm going to stop the video here, and we're going to continue on with the standard deviation, the mathematical calculation of it, the 6 steps that you saw from the previous video, from, you know, the one before this. We'll go through those 6 steps and calculate the standard deviation. So, you know, hold off before you call instructors, because you're going to have to watch, you know, several of these videos again and again to get it. I mean, it is all in the textbook, okay? But once we get through this next video, if you still don't understand something, then, you know, telephone and speak with an instructor, okay?